In this section, we're talking about solving linear equations. In order to do that, we want to first develop a general strategy for solving equations, which initially might not make a lot of sense as we map this out, but then you'll have that as a guide to refer back to as we work through some of these different steps. Our first step will always be to simplify each side of the equation. So essentially, don't worry about the fact that there's an equals, just look at the left-hand side, simplify as much as you can, do the same on the right-hand side. Once we've taken care of all of those simplification steps, we'll want to collect all of our variable terms on one side of the equation, and then collect all of our constant terms on the other side of the equation. Our next step then will be to multiply the variable term by the reciprocal of its coefficient. Like I said a minute ago, as we write out these steps, they may not necessarily click for you. Don't worry about that. We're just kind of creating a guide that we'll reference back to. But keep in mind, whenever we talked about variable terms, x always has a coefficient. If one's not listed, we can infer that it's 1 times x. Whatever that coefficient is, in this case a, when we say multiply by the reciprocal, what we mean is 1 over that value. So 1 over a would be the reciprocal of a. We'll multiply both sides by the reciprocal of whatever that coefficient is, and then our last step, which I would highly emphasize, not enough people ever do this, is to check your solution. If you check your solution, you won't fix a mistake that you made, but you'll either know that the answer that you came up with is correct, or know that you need to go back and verify a couple of steps and try to identify where you went wrong. Now that we have that roadmap, we'll apply that in example 1 as a process for solving this linear equation. First, we'll look at simplifying everything on the left-hand side, since the right-hand side is as simplified as possible. To do that, we're going to take this negative out front and distribute it through, which will give us negative t plus 28 is equal to 34. Now that all the simplification is taken care of, we'll look at collecting all of our variable terms on one side of the equation. In this case, we have negative t already on the left-hand side. So we'll move on to collecting our constant terms on the right-hand side. Keep in mind we can perform any operation to one side of the equation as long as we do the exact same thing on the other side. Since we have plus 28 on the left-hand side, we'll subtract 28 and subtract 28 on the right-hand side. Doing that will leave us with negative t, and while we don't need to write it, I'm just going to put it in as a placeholder, plus 0. So that constant term on the left canceled out, and then on the right we get 34 minus 28, or 6. Keep in mind, since we have negative t, that would be the same thing as negative 1 times t equal to 6. We're down to the step where we want to multiply both sides by the reciprocal of that coefficient. The reciprocal of negative 1 would be 1 over negative 1. So we'll multiply both sides by 1 over negative 1. On the left-hand side, negative 1 over negative 1 will cancel. This will leave us with just t. And on the right-hand side, we'll have 6 over negative 1, which is the same thing as 6 times negative 1, or negative 6. So we get t equals negative 6, which we can check by taking that value and plugging it back into the original equation. So we'll have the opposite of the quantity -6 minus 28, which will give us -6 minus 28 will be -34 or +34. Since that equals what we had on the right-hand side, this checks out. Our solution is the correct solution for this equation. In example 2, we start off the same way. We want to simplify as much as possible. That means on the left-hand side, -12 will remain unchanged, but we'll distribute that 18 through to get 18 times 4, or 72, minus 18k. And all of that will be equal to that 3 on the right-hand side, which is already simplified. Combining like terms on the left-hand side will give us 60 minus 18k is equal to 3, and we've finished all of our simplification. From here, we'll look at collecting those like terms on the same side. So we'll subtract 60 from both sides to give us minus 18k is equal to -57. Once we have that variable term isolated, we'll look at that coefficient, which in this case is -18, and multiply both sides by -1/18, or 1/-18, which is the same thing. On the left-hand side, those coefficients will cancel out, leaving us with k is equal to -57 over -18. Those two negatives will cancel, leaving us with 57/18. Which we could plug into a calculator and round to approximately 3.1667. We can check this result too, but in this case it's going to be to our best advantage to use technology, and we're going to need to keep in mind that we want to use the exact value of 57/18. If we plug in that rounded value, our check won't come out quite right. It'll be very close. But we can use that 57/18, and we can evaluate -12 plus 18 times 4 minus 57/18, and see that that comes out to exactly 3, which is what we had on the right-hand side to begin with. Since that checks out, we know that we came to the right solution. Taking a look at one last example here of applying this general solving strategy, we'll distribute that 10 through to get 110 minus 10x minus 15 is equal to 2. Combining like terms on the left-hand side will give us 95 minus 10x is equal to 2. We'll subtract 95 from both sides to get -10x is equal to -93. And then again, we'll look at what that coefficient is. This tells us to multiply both sides by -1/10. Which is going to give us x is equal to 93/10, since those two negatives will cancel out. In this case, this comes out to be exactly 9.3. Again, we could manually, or using technology, plug that 9.3 back into the original expression and see that that would equal 2 on the other side, which would verify that we have the correct answer.